Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to show you how to identify the unknown metal in a compound when you're given the amount of the compound that you start with and the amount of product that is formed from this compound. So let's get into this. So here we're given a sample of M2O3 weighing 11.205 grams, and we're told it's converted to 15.380 grams of MCl3, where M is an unknown metal, and they want us to identify M. So how in the world do you do this problem? So here's the thing. We have to look, we know that we're given a certain mass of our unknown compound. Unknown in the sense that we don't know what the metal is, but we do have the formula M2O3, and we're told that it's converted completely into 15.380 grams of MCl3. Now, they don't give us any reaction. They don't tell us what the reaction is. They just give us the two formulas. But that is enough, because notice when you go from M2O3 to MCl3, we know that we have oxygen in our original sample. All the oxygen is gone, and the metal is now combined with chlorine. Now, we can assume that all of the metal that was here ends up here. So notice that I have a 2M here, but I only have a 1M here. So whatever number of moles of this substance that forms, in order to get the same number of moles of M, here I have 2 moles of M on this side. Again, because of the conservation of mass, we need to balance the equation. And so as far as having 2 moles of M on this side, we should have 2 moles of M on this side. And so we can add a coefficient. And so we know that 1 mole of this substance should give us 2 moles of this substance in the balanced equation. We don't need to know what everything else is. This gives us a mole ratio. Okay, so that's number one. Number two, they give us the starting amount of the M2O3, and they give us the ending amount of this in mass. Well, to help us figure out what the identity is, we need to know what the molar mass of M is. So if we could find, right, the grams and the moles of M, we could divide those and we'll get the molar mass and look on the periodic table for our element. But in this case, that would be hard to do because we don't know the mass of M. We don't know really the moles of M either. That's not really given to us. We're given the masses of the compounds, but not the elements in the compounds. But there is a way, maybe we could figure it out from the mass here. We do have a ratio here. So if we could get the percent mass of that, but again, we don't know what the identity of the substance is, so it would be hard to get a percent mass from this. So how do we go about solving this? Well, the key is, since they're giving us the mass of our starting material and they're giving us the mass of our ending material, we could do a mass to mass conversion. We could just set up our equation just like we would for doing a mass to mass conversion. So if they gave me 11.205 grams of M2O3 and they asked me to convert or find the mass of MCl3 that was formed, I would have to do a mass to mass conversion. So I would have to take the mass of my beginning substance, use the molar mass of that to convert to moles, then use the mole ratio to convert to moles of my new substance, and then use the molar mass here to convert to grams. So they already gave me the beginning and ending, so all I have to do is fill in the middle part. So let me show you what I mean. So I start off with 11. I'm going to give myself some room. I'm going to start off with 11.205 grams of M2O3. That's the formula of the substance over 1. Now, what do I want to do? My first step in a mass-to-mass conversion is to convert the grams to moles using the molar mass. But I don't have the molar mass of the substance. If I knew what M was, all I would do is look on the periodic table, add up the molar masses of 3 atoms of oxygen, add up the molar masses of 2 atoms of M, add that together, and I would have my molar mass. But in this case, we're trying to find the molar mass of M. So what I can do is I can write the molar mass of the formula in terms of M as the molar mass of M, right? So what do I mean? So if I could add this up, so the molar mass of M is going to be equal to 2 times the molar mass of element M, whatever M is. So I'll just say M for the molar mass of M, okay, plus 3 times the molar mass of oxygen, which is 15.9994 grams per mole, right? And so when I add this together, when I calculate this, what do I get? I get the molar mass of 2M plus, and then 3 times that. What do I get for that? I get 47.997. And let's write this as moles here. So grams per mole. And so this is going to be 47.997 grams per mole. So now this is going to be, oops, not the molar mass of M. This is the molar mass. Oops. This is the molar mass of M2O3. So now that I have the molar mass of M2O3, I can use this as part of my conversion factor in terms of the number of grams per mole. So now when I set up my conversion factor, the grams goes on the bottom. Well, how many grams? It's going to be 2 times the grams per mole of M plus 47.997 grams per mole of the oxygen. So that's going to go on the bottom. So it's going to be 2M plus 47.997, and that's going to be grams. And then on the top, it's going to be mole. So 1 mole of M2O3 oh, this is M2O3. Okay. So here I have grams. So the grams of M2O3 cancel out. I have moles of M2O3. So now I can use the mole ratio to convert from moles of M2O3 to moles of MCl3, which I get here. So 1 mole of M2O3 is going to give me 2 moles of MCl3. So then I put 1 mole of M2O3 on the bottom, and I have 2 moles of MCl3 on top. So moles of M2O3 cancel out. Now I have moles of 2 moles moles of MCl3 on top. Now, what do I want? I want grams of MCl3. So I'm going to now use the molar mass of MCl3. But again, I don't know the molar mass of M, so I have to use M in, I have to calculate the molar mass of MCl3 in terms of the molar mass of M. So in this case, so the molar mass of MCl3 is going to be equal to M, whatever the molar mass of M is, plus 3 times the molar mass of Cl. So it's going to be 3 times the molar mass of Cl. And the molar mass of Cl is going to be, let me take a look here. Give me a second. $35.45. And that's going to be grams per mole. So when I calculate this out, it ends up being the molar mass of M plus 106, what'd I get? 106.35. So 106.35. And so that's going to be grams per mole. So now I have the molar mass of MCl3 in terms of molar mass of M plus that of chlorine. So now I can use that as a conversion factor to convert to grams. So this time the moles are going to be on the bottom. So 1 mole of MCl3 on the bottom. And then this grams on top. So it's going to be M plus 106.35 grams. And that's going to cancel out. So moles of MCl3 is going to cancel out. Now I have grams of MCl3. And that calculated out should give me the 15.380. So 15.380 grams of MCl3. So I hope you follow along with me so far. So now I have set up here an equation where all I've done is I've taken the mass of the M2O3 that I was given, and I set up the conversion factors that I would need to convert it to grams of MCl3, which is what they gave me. So this side of the equation should equal this side of the equation. So I have one equation, one unknown. The unknown is M, which is representing the molar mass of the unknown metal M. So now at this point, all I have to do is simplify this, do the calculations, and solve for M. So let's go ahead and simplify this. Let's clean this up a bit. So as you would normally do on any conversion factor problem, you're going to multiply by everything on the top. You're going to divide by everything on the bottom, and you'll get this all cleaned up. So when I do that, I get, let's see, 22.41 grams. So I'm going to get 22.41 grams okay? And that's because I'm multiplying this by 2 and then multiply that by M plus 106.35. Okay. Actually, this is multiplied. And then, of course, grams is going to be on the bottom. That's going to be MCl3. And then, I'm sorry, on the top. So, and then on the bottom, I'm multiplying this by all ones. So it's just going to be 2m plus 47.997. Okay. And then all this is equal to that side, which is 15.380 grams of MCl3. Okay, so now we're going to clean this up a little bit. So here, now I got to kind of do the FOIL method. I got to multiply this out here. And so when I do that, I'm going to get 22.41 times M. And then I multiply these two together. I'm going to get, what do I get? I'm going to get let's see, 2383. 2383.3035. Okay, and that's going to be, let's see, grams. Okay. And so then we've got this here. So I can take this here. I'm going to multiply both sides, right? If I multiply both sides of this, so then this is going to be 2m plus 47.997, right? If I multiply both sides to this, then I can multiply that on this side as well. So it's going to be 2m plus 47.997, right? So then this is going to cancel out, and then this is going to be multiplied together. So then this is going to be equal to this here. So if I multiply this out, I'm going to get 15.380 grams multiplied by 2. Oops, I forgot the 2. So that's going to be 30.76 grams. 30.76 grams M, right? Because I multiplied by M. And then I'm going to multiply this by this. And when I do that, I get, what did I get? 738.19, 738.19. Let me see here. .386, sorry. So let's just say 38. Okay. And so now all I need to do is get the like terms together. So I have an M term here and an M term here. So I can subtract this, so if I subtract 22.41 M from both sides, 22.41 M from both sides. When I do that, I get 8.35. So I'm going to get 8.35 M. And then if I subtract this from both sides, so if I subtract 738.1938 from both sides, so I subtract that from this side as well, I get minus, I'm going to subtract 1938. And when I subtract this, I get, what do I get? I get 1645. I got 1645.109. And so you'll notice that I dropped the grams here because we're going to be solving for the molar mass of this anyway. So now, and I kind of dropped it here too, so you don't really need to worry about that. And so when we now solve for M, because M, it represents the molar mass. So then we're going to divide by 8.35 on both sides. 8.35 on both sides, and we get M is equal to 197.02. 197.02 grams per mole. So we look up on the periodic table, what is the closest element that has a molar mass or an atomic mass of 107.02? If we look that up, we get gold. Gold has a molar mass of 196.97. 196.97 is the closest to 197.02. So the identity of this unknown element is gold. Gold is the answer. So I hope this was helpful. If you enjoyed this video, if this has helped you in any way, then by all means, like this video, share this video, subscribe to my channel, hit that notification bell. When you do, make sure you click all so you'll be notified by all the videos I put out. Don't forget to hit the click button somewhere over here. Also, make sure you put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a topic you want me to cover, if you've got a question or a problem you need help with, put that down below. I would love to help you with that. Thanks for joining me and have a great day.